for cows were still seen roaming around the highlands yesterday. LMPD says 3 of the last 4 cattle were finally caught around 9:30 last night near Baxter Avenue. In 1871, a small group of farmers abandoned their settlement in Amsterdam Island, leaving behind something unexpected, a handful of cattle. With no humans to tend them, no lush grasslands and harsh subantarctic conditions, the cows should have perished. But they didn't. A volunteer from West Virginia was able to corral them to safety. Over a century later, explorers and researchers were stunned to find not a few survivors, but thousands. What happened in the silence of that forgotten island? How did a domestic species defy nature, thrive, and ultimately force a moral dilemma that would divide the scientific community? This is a haunting, incredible tale of the Amsterdam Island cows, an evolutionary mystery born from abandonment, survival, and the cost of second chances. The island and its initial inhabitants. Far out in the endless expanse of the southern Indian Ocean lies a volcanic remnant shaped by fire and wind. Amsterdam Island. Barely 55 square kilometers in size, it's often overlooked on even the most detailed maps. Harsh winds lash its cliffs. Waves crash endlessly against blackened shores, and clouds seem to cling stubbornly to its jagged silhouette. To most, it is the very definition of desolation. But for a brief moment in history, this unforgiving rock became the setting for one of the strangest ecological stories ever recorded. A story born of hope, neglect, and an accidental experiment that no scientist could have ethically planned. In 1871, a man named Herta, an ambitious farmer from the French colony of Réunion, arrived on Amsterdam Island with a vision. France had long viewed its remote territories as untapped resources. To colonial authorities, Amsterdam offered potential, a strategic outpost, perhaps even a base for whaling or agriculture. Heron's idea was simple: establish a small farming community where livestock could be raised in isolation, free from disease and competition. Along with his fellow settlers, he brought with him a handful of hardy cattle, 4 cows and a bull, chosen for their resilience and productivity. The exact breeds are not definitively recorded, but based on what was common in Réunion at the time, they were likely drawn from robust European stocks, such as the Jersey Tarentaise or Breton Black Pie. These cows were meant to be the foundation of a new agricultural colony. Heron and his group hoped to cultivate crops, raise livestock, and build a foothold on the island's windswept plateau. But from the moment they arrived, the settlers were faced with obstacles far greater than they had imagined. The island was no pastoral paradise. It was a crucible of extremes. The climate was cold and damp, far removed from the warm tropical air of Réunion. Gale-force winds tore across the landscape. Rain was frequent but not always helpful, and drinkable fresh water was scarce. The volcanic soil was acidic and unforgiving. Crops failed. Livestock wandered. Morale withered. Isolation took its toll. After just 7 grueling months, Heron and the others gave up. Their dream of a remote farmstead collapsed under the weight of Amsterdam's brutal indifference. They packed their belongings and returned to Réunion defeated. But in their haste, or perhaps due to the difficulty of transporting animals by sea, they left behind their 5 cattle. That decision, seemingly inconsequential at the time, set into motion one of the most bizarre and revealing ecological events of the modern era. With no humans to feed or shelter them, the cattle were thrust into survival mode. The island was no easy home. Its vegetation was limited, with only small pockets of Filica arborea forest, low grasses, mosses, and shrubs. The cattle, domesticated for centuries, were suddenly wild again, cast into an evolutionary time warp with no one to watch. Yet the island had no predators. The cows, despite the sparse landscape, found a way to survive. They browsed on whatever vegetation they could find: grass, shrubs, bark, even mosses. They adapted quickly, reverting to their primal instincts. Over time, they began forming loose herds, migrating across the island's ridges and valleys in search of food and water. And somehow, they multiplied. By the mid-20th century, scientists and sailors who visited the island began to notice something peculiar. There were cattle everywhere. Not just a handful, but hundreds. They roamed freely, grazing the hillsides, wandering among seabird colonies, and trampling native flora. It was an ecological paradox. How could domestic species not only survive but thrive in one of the world's most isolated, nutrient-poor environments? What began as a failed colonial experiment was now a living mystery. The cattle of Amsterdam Island became one of the few true feral populations of Bos taurus in the world. Over the decades, they had undergone subtle changes. Isolated from human contact, they began to shrink in size, a phenomenon known as insular dwarfism, common among island species. Their coats thickened, their behavior shifted. They had become more skittish, more aggressive, more attuned to the rhythms of the island. Generation after generation, they adapted, living proof that evolution, when left unchecked, could work astonishingly fast. Still, no one quite knew what to make of them. The French scientific community, when it finally began studying the island in earnest in the 20th century, found itself divided. Some viewed the cows as a fascinating anomaly, a rare chance to observe domesticated animals reverting to wildness in real time. Others saw them as ecological vandals, non-native invaders destroying fragile ecosystems and crowding out endangered seabirds like the Amsterdam albatross. Amsterdam Island, once silent and still, had become the stage for a new drama, one that would pit science against conservation and raise unsettling questions about what we owe to nature, to science, and to the accidental legacies we leave behind. In the wake of Heron's departure, the cattle had not merely survived. They had claimed the island for themselves, and they had done so while humanity wasn't watching. It would take over a century before we truly understood the scale of their impact. And by then, the question wouldn't be whether the cows could live on the island, but whether they should. Against all odds, survival and proliferation. When Heron and his fellow settlers sailed away from Amsterdam Island in 1871, they likely thought the cattle they left behind would die within weeks. There was no one to care for them, no barns to shelter them, no dependable supply of fresh water, and the island's meager vegetation offered little promise. But nature, when left to its own devices, has a way of surprising us. And on Amsterdam Island, it did so in the most unexpected way imaginable. Somehow, those 5 cattle survived. Not only that, they flourished. The key was adaptation. Despite the subantarctic conditions, the cows tapped into dormant instincts buried deep in their genetic code. They began behaving more like wild bovines, roaming in loose groups, grazing, and seeking shelter in volcanic hollows and beneath scrubby trees. The lush fields they once relied on were gone, but they made do with the native vegetation, gnarled shrubs, clumps of grass, mosses, and even bark when nothing else remained. They scavenged, they moved constantly, and most critically, they reproduced. Without predators or humans to keep the population in check, the herd began to grow, slowly at first, then exponentially. By the mid-20th century, visitors to the island began reporting startling numbers of cattle, dozens at first, then hundreds, then thousands. By the late 1980s, their numbers had ballooned to an estimated 2,000 animals freely roaming the island's narrow ridges and plateaus. It was a population explosion in one of the least hospitable environments on Earth. But the cow's survival came at a cost. Amsterdam Island, though visually rugged, hosted a delicate and unique ecosystem. Much of the island's native vegetation was already sparse and slow-growing, shaped by centuries of harsh winds, volcanic soil, and isolation. The small forests of Phyllica arborea, an endemic tree species, were not built to withstand the constant trampling and grazing of large herbivores. Over the decades, the cows destroyed entire swaths of forest. They ate the young saplings before they had a chance to mature. They stripped bark, uprooted shrubs, and carved trails through once undisturbed moss beds. More troubling still was the impact on the island's native bird species. Amsterdam Island is home to several rare seabirds, including the Amsterdam albatross, a critically endangered species that nests only on this single island. The cattle, oblivious of the ecological significance of their new home, disrupted nesting grounds, crushed eggs underhoof, and altered the landscape so dramatically that bird populations began to suffer. To the untrained eye, the island might look alive and vibrant, teeming with large mammals where none should exist. But beneath that illusion was a quiet ecological crisis. The island's natural balance had tipped, perhaps permanently. By the time scientists began conducting formal ecological surveys in the 1980s, it was clear that the cows, however fascinating, were wreaking havoc. Yet their presence also presented a remarkable scientific opportunity. Here was a domestic species, Bos taurus, that had lived wild and unattended for over a century. It was a living case study in fertilization, a rare chance to observe how domesticated animals revert to a wild state when left in isolation. Researchers noted several significant changes. The cows were smaller, an example of insular dwarfism, where island species often shrink due to limited resources and space. Their average weight had dropped from an estimated 553 kilograms in domesticated breeds to around 410 kilograms. Their behavior had shifted too. They were more aggressive, more alert, less tolerant of humans. They formed small scatter herds and adapted their feeding patterns to match the island's inconsistent plant cycles. Even their genetic profile had begun to shift. DNA studies in the 1990s and 2000s revealed signs of inbreeding, but also adaptation to the unique pressures of the island environment. In just over a century, a blink in evolutionary terms, the Amsterdam island cattle were already diverging from their ancestral lineage. Evolution, it seemed, was not a slow march, but a fast and reactive dance dictated by necessity. But scientific curiosity came with ethical conflict. Could this accidental feral herd be allowed to continue its experiment at the cost of an entire island ecosystem? Should humanity preserve the cows as an evolutionary marvel, or remove them in favor of restoring native species pushed to the brink? Those questions would come to dominate the next phase of Amsterdam Island's story. But at this point in the tale, in the late 1980s, the cows had the run of the island. Their hoof prints crisscrossed every slope. Their trails led down to watering holes and up to nesting cliffs. They grazed on vegetation older than any living person. They drank from puddles formed in ancient lava flows. In their eyes, the island was theirs and had always been. There was no memory of humans, no memory of barns or fences, no trace of the hands that once fed or milked them, only instinct, endurance, and the silent rhythm of a herd that had learned to survive on its own. Their survival was no miracle. It was a testament to biology's stubborn will to endure, but it was also a warning. When species are introduced carelessly into fragile systems, even something as simple as a cow can become an unstoppable force. And the consequences of that force were just beginning to be understood. From domestic to wild, feral life, to the cattle that roamed Amsterdam Island in the 20th century, the notion of being domestic had long lost its meaning. Their ancestors may have been milked by hand, led by ropes and corralled behind fences, but those memories that faded generations ago, burned away by the harsh winds and isolation of their rugged new home. By the time scientists began observing them closely, the cows of Amsterdam had become something entirely different. A wild species forged not by human design, but by nature's unforgiving hand. They had become truly feral. This wasn't just about escape or survival. Feralization is a biological and behavioral transformation, a complex reversal of domestication. It's a process by which animals that once relied on humans adapt to living entirely without them, often rediscovering instincts buried beneath centuries of selective breeding. And in the case of the Amsterdam Island cattle, this transformation was both rapid and profound. Early observations noted behavioral changes that distinguished the cattle from their mainland counterparts. They were more cautious, more aggressive, and more independent. When approached by humans, they bolted quickly or lowered their heads in warning. Unlike domesticated cattle, which gather around fences or people in curiosity or hunger, these cows kept their distance. Their eyes, once dulled by predictability, now gleamed with wariness. Social dynamics shifted as well. Without the interference of farmers, the herd developed its own hierarchies. Dominant bulls maintained small groups of cows, engaging in frequent territorial disputes. Calves were raised within tightly knit circles, and mothers were fiercely protective. Life on the island was raw, and the cows had learned to treat everything, including the few humans who visited, as potential threats. Their diet, too, reflected their new reality. Gone were grain feeds, hay bales, and cultivated pasture. In their place, a forager's menu of low shrubs, mosses, ferns, and whatever seasonal greenery they could locate. The lack of consistent grazing led, to more frequent migration. The herds moved constantly, traversing volcanic ridges, descending into craters, and climbing steep wind-lashed cliffs in search of nourishment. But perhaps the most fascinating changes weren't immediately visible. In the early 1990s, and again in 2006, researchers conducted genetic studies on the Amsterdam cattle population. What they found was astonishing. Despite the original herd comprising just 5 animals, the population had maintained a surprising level of genetic diversity. Those signs of inbreeding were beginning to emerge. Still, this small, closed-off group had undergone real genetic drift. Most cattle trace their ancestry primarily to the Jersey breed, with evidence of interbreeding from other strains likely present in the founding stock. But after over a century of isolation, these cattle had developed distinct traits suited to island life: smaller stature, thicker coats, stronger hooves, and leaner builds. They averaged about 410 kilograms, noticeably smaller than the average weight of their ancestors, who likely tipped the scales at over 550 kilograms. This size reduction, known as insular dwarfism, is common in island species where resources are scarce. Scientists were intrigued. In the controlled chaos of the island, nature had sculpted a new kind of cow, one uniquely adapted to an environment its ancestors were never meant to endure. It was evolution at high speed, unfolding not over millennia but over a few human generations. Unlike domesticated cattle, which gather around fences or people in curiosity or hunger, these cows kept their distance. Each calf born was one step further from domestication, one step deeper into the unknown. But this was not without cost. Fertilization came with health risks. Without veterinary care, diseases went untreated. Parasites spread through the herd unchecked. Calving was dangerous, and injuries often meant death. Many animals bore scars, limped from old wounds, or suffered from malnutrition during particularly lean seasons. The island was not kind, but it was consistent, and the cattle endured, adapting again and again. To the scientific community, the herd was both a marvel and a dilemma. Here was a real-time experiment in adaptation and survival. The Amsterdam cattle had become one of the very few known examples of long-term feral bovine populations anywhere in the world. Their behavior, physiology, and genetics provided rare insight into how quickly evolution can operate under extreme conditions. But to conservationists, the story had a darker side. The cattle may have been adapting brilliantly, but their presence was devastating the island's ecosystem. Overgrazing, soil erosion, destruction of native flora, and the trampling of seabird nesting sites were all escalating. The cows had found their niche, but only by shoving everything else out of theirs. So the question began to shift. What mattered more, the cows' remarkable evolution or the island's fragile native life? In this quiet war between survival and preservation, the cows stood unaware at the center. They knew nothing of the debates unfolding in Paris and Réunion. They knew only the rhythm of wind and hunger, of mating and migration. To them, Amsterdam was their homeland, harsh and real, but entirely theirs. They had earned their place not through design, but through grit. No longer symbols of domestic utility. They had become living proof of life's relentless will to adapt. But how long could that adaptation continue? The answer would come soon, and it would reshape not just the island, but the legacy of the Amsterdam island cattle forever. Evolution observed. Evolution is often imagined as a slow process, unfolding over thousands or millions of years. But the cows of Amsterdam Island defied that timeline. In just over a century, they underwent dramatic physical and behavioral changes. So much so that by the 1990s, they were considered a unique feral population unlike any cattle elsewhere in the world. One of the most striking changes was their size. Researchers discovered that these cattle were significantly smaller than their ancestors. Where mainland cattle typically weighed 550 to 600 kilograms or more, the Amsterdam cows average around 410 kilograms. This wasn't genetic disorder or the result of inbreeding alone. It was a textbook case of insular dwarfism, a phenomenon where large animals on islands evolved smaller bodies to adapt to resource limitations. With no lush pastures and limited fresh water, the cows' bodies responded in kind. Smaller size meant lower energy needs, improved heat conservation, and better chances of survival in lean seasons. Over time, generation after generation, this trait solidified, etched into their DNA by necessity. In addition to shrinking, the cattle developed thicker coats, longer limbs relative to their body size, and more muscular frames, signs of animals designed by nature, not by man. These changes excited evolutionary biologists. The Amsterdam herd had become a living experiment, a window into how quickly domesticated animals could revert to wild states when left to fend for themselves. Unlike zoo animals or controlled rewilding projects, these cows were truly independent. Their transformation was unsupervised, unintentional, and utterly authentic. But this fascinating evolutionary story was unfolding against a backdrop of destruction. By the 1980s, the consequences of the cow's success were becoming impossible to ignore. The herd had grown to nearly 2,000 individuals, and their impact on the island's ecosystem was devastating. The once dense Filica arborea forests, critical for bird nesting and soil retention, were being consumed before new growth could take root. Soil erosion was rampant, and most alarmingly, seabird populations, including the endangered Amsterdam albatross, were plummeting due to habitat destruction. In 1987, the French government erected a 4-kilometer fence across the island to divide it in half. The idea was to protect the northern portion, home to the last viable bird nesting grounds, and isolate the cattle in the south. This fence marked the beginning of a controversial campaign, eradication. Between 1988 and 1989, over 1,000 cattle were culled from the southern half of the island. Over the following 2 decades, a more gradual reduction continued. In 2007, the final decision was made. The remaining cattle would be eliminated entirely. The last of the Amsterdam Island herd were slaughtered between 2008 and 2010. The decision ignited a fierce debate. On one side were conservationists, arguing that the cattle, no matter how unique, were an invasive species wreaking havoc on a delicate and endangered ecosystem. The birds, the plants, the soil, all were suffering, and many of the island's native species existed nowhere else on Earth. For them, the choice was clear. The cows had to go if the island was to be saved. On the other side stood scientists, ethicists, and animal welfare advocates who saw the herd not as pests, but as a precious genetic and evolutionary resource. They argued that these cattle, shaped by a century of isolation, held clues about adaptation, genetic drift, and fertilization that could benefit broader scientific understanding. They weren't just cows, they were living data. Why not relocate some to another island, or establish a conservation enclosure elsewhere? But logistics, funding, and politics made such solutions difficult. In the end, ecological preservation won. The cows, once left to die, had been slaughtered after surviving against all odds, and with them, a living evolutionary experiment was erased. In the end, the story of the Amsterdam Island cattle is not just about cows. It's about unintended consequences. A failed colonial dream planted the seeds of an ecological experiment. Abandoned livestock, forgotten by history, defied extinction and carved out a place in the wild. In doing so, they created both wonder and destruction. Their journey, from domestication to wildness, from survival to culling, poses uncomfortable questions. What do we do when scientific value and environmental preservation are at odds? Who decides what species deserve to live, and what species must be sacrificed for the greater ecological good? Amsterdam Island has begun to heal. Native forests are regrowing. Seabird populations are recovering. In that sense, the eradication worked. But something was lost in the process. Something irreplaceable. And so here's the question. If you were faced with saving an entire ecosystem by erasing a single unique species, could you do it? Would you preserve nature as it once was, or protect what it had unexpectedly become? Share your thoughts in the comments below. Thank you for watching. See you in the next one.